Imagine if your alarm clock suddenly started going off earlier every year. That's essentially what's happening to plants and animals around the world. Climate change isn't just making things warmer, it's resetting nature's internal clock, causing species everywhere to advance or delay the timing of their most important life events. In this video, we're looking at real examples of how certain species are shifting their schedules with changes measured not just in days, but sometimes in weeks or even months. Let's start with plants. Some of our best measures of change are possible because people carefully documented when various plants leafed out and bloomed hundreds of years ago. By comparing observations collected today with those records collected hundreds of years ago, we can see clear evidence of change in many species. In New York, tulip tree now flowers 27 days earlier than back in the early 1800s. That's a change of nearly a month over 2 centuries. This major shift appears to be largely the result of steadily increasing temperatures in this region. It's not just in North America, though. In Switzerland, horse chestnut trees now leaf out about 11 days earlier than they did in the 1800s. These trees, famous for their eye-catching white flower spikes, are also responding to warmer temperatures by starting their growing season measurably earlier. But the changes aren't uniform across species. While many plants are advancing their spring activities, some are demonstrating much larger shifts than others. Going back to New York, where tulip tree is demonstrating that very dramatic advancement, other species are showing more muted changes. Common lilac is now flowering about 10 days earlier than it did 200 years ago. Yellow trout lily is flowering about a week earlier, and black cherry trees are flowering about 3 days earlier. And not all timing changes involve things happening earlier. Climate change can also push species in the opposite direction. For example, in North Dakota, smooth sumac now flowers about 10 days later than it did about 100 years ago. Some species appear to be doing nothing at all, and this is turning out to be a poor survival strategy for them. Using observations collected in Concord, Massachusetts by Henry David Thoreau, researchers at Boston University have shown that St. John's wort, a perennial plant with bright yellow flowers, has not changed its flowering time much at all since Thoreau's date, and as a result, it is far less abundant on the landscape than it was when Henry was tracking its flowers. Aquatic species are experiencing some of the most dramatic timing shifts of all. Fish are spawning earlier as water temperatures warm. Aquatic insects are also emerging earlier, creating cascading effects throughout marine food webs. In Narragansett Bay, Rhode Island, the marine ecosystem is undergoing rapid and substantial changes. The average water temperature in Narragansett Bay has increased by about 4 degrees Fahrenheit since the 1960s. This seemingly minor change is driving massive shifts in which species live there and when they're active. Fish that migrate to the bay for the winter, like the longhorn sculpin and ocean pout, have dramatically shortened their stays, in some cases by 2 to 3 months. And on the flip side, summertime residents are staying in the bay for much longer, in some cases by more than 2 months. These are just a few of the many examples of how species are adapting the timing of their activity to keep pace with rapidly changing conditions. There's a lot we know, but there's also a lot we don't know. We actually need many more observations of when plants and animals are undergoing their seasonal transitions to better understand how climate change is reshaping the timing of life on Earth and consequences for these changes. Your observations to Nature's Notebook are helping scientists detect trends, predict future changes, and develop strategies to help both wildlife and human communities adapt to our changing climate. Thank you for your efforts.